Algebra I Honors, Lesson 4.1, the coordinate plane. Lesson 4.2, transformations on the coordinate plane. So, coordinate plane, that's it on the right here. You've got the x-axis, the y-axis. So let's start labeling them. This is, if you've never seen it before, just the way we do this. There's other ways to do it, but this is the one we're going with for now. So that's the y-axis. The origin is labeled with O, and it's in the middle. It has coordinates 0, 0. Just a big O, not a 0, O. In the quadrants, we have quadrants 1, 2, 3, 4. No sense they're in counterclockwise. No particular reason they start in the top right. That's what we got. So what are the x-coordinates and the y-coordinates? What do they form? Well, the x and the y coordinates together form the coordinate plane. I hope and pray you never see this. I believe the x is called the abscissa and the y is called the ordinate. I'm not even going to write them down, so I hope you never get into that. But now the key is, how do we chart them? So A, you just count 1, 2, 3, 4, 5, 6, 7, and you're going negative, so that's -7. Then you go up 1, 2, 3, 4, you're going up, so it's 4. The ordered pair is -7, 4, and that's in quadrant 2. B is 1, 2, 3, and down 2. 3 right, positive, down 2, negative. 3, -2, and that's in quadrant 4. C is 1, 2, 3, 4, 5, 1, 2, 3, +5, +3, 5, 3, and that's in quadrant 1. D is -1, 1, 2, 3, 4, 5, 6, -6. That's in quadrant 3. And E is 1, 2, 3, 4, 5, -5, 0. And that is not in a quadrant. That's called the quadrantal. And it's actually on the x-axis, the negative x-axis to be precise. So pause it, see if you can label where all these belong. I'm going to go and do it now. A, B, C, D, E, F. No rocket science, nothing major going on. Just that's how you do it. So now we're going to get into something called transformations in the coordinate plane. It's actually an extraordinarily complex subject that we're just going to give you a taste of. So if you get lost, don't worry about it. It happens. It's not the end of the world. 4 of them, the transformations. These are all transformations. So a reflection, translation, dilation, rotation. Notice translation and transformation are 2 separate things. Reflection means just copy it over a line. Translation means just move it up, down, left, right, up and right, down and left, whatever you want. Dilation means stretch it up, make it bigger, or stretch it down. It has to have a point that it's dilated about, and a figure has to be rotated about a point, so it's turned on its side. So now you just practice. I would pause this, give it a shot on your own. This is a rotation. This is a reflection. It could also be a rotation, but it's shown as a reflection. You could imagine it's being rotated about that point, just being spun around, but it's shown as a rotation. This is a dilation. And this is a translation, not a transformation. They're all transformations. This is a translation. So here's an example. You have a parallelogram, negative 4, 3, 1, 2, 3, 4, 1, 2, 3. That's A. B, 1, 1, 2, 3, 0, 1, and negative 5, 1. This does not look like a parallelogram to me, so I must have screwed up. Hey, there it is. B, C, D. Reflect it over the x-axis and find the coordinates. So, this is the x-axis. Reflect it over. I like to count 1, 2, 3, then go 1, 2, 3. So they want the coordinates. I'm going to draw it in, and I'm going to label it. The way we label it, when we do something to it, we put this little tick mark up above it and call it prime. So this is A prime, this is D prime, this is C prime, this is B prime. B prime is not B prime. Wow, got them all wrong. Yeah, just shows you it's challenging. So B prime is 1, negative 3. C prime is 0, negative 1. D prime is negative 5, negative 1. A prime is negative 4, negative 3. That's it. Doing problems. Graph a triangle. Negative 2, 3. 1, 2, 1, 2, 3. That's A. 4, 0. 1, 2, 3, 4, 0. That's B. 1, 2, 1, 2, 3, 4, 5. That's C. Label the coordinates of the vertices of the image if we're going to translate it. 3 down, 3 to the left, and 2 down. 1, 2, 1, 2, 3. A prime. 1, 2, 1, 2, 3. B prime. Gonna have a coordinate here. I gotta go figure it out in a minute. One, 2, 3, 1, 2. C prime. Now it's at negative 1. 1, 2, 3, 4, 5, 6, 7. It's at 1, comma, negative 2. Negative 5, comma 1. And I graphed it in its image. Oh, or never did connect the dots. Now, you'll know if you screwed up, it doesn't look exactly the same. Just shift it over a little bit somewhere. It does. It looks exactly the same. Notice this isn't particularly challenging. It's just fairly tedious. There's a lot going on. So we're going to dilate an image here. Negative 4, 1. It's L. 1, 4. Nearly did it wrong again. 7, 0. And negative 3. Negative 6. That's P. Find the coordinates of the dilated trapezoid. If we make it 3/4 closer, something missing. We need a point. Now, if it's on the coordinate plane, you could always assume it's done around the origin. 3/4 is tough, because it's easy for this one. It's negative 3, but this one's kind of a weird little negative 3, comma 3/4 or something like that. and I certainly don't have enough room to do that. So I will put L prime here, negative 3 comma negative 3/4. It was impossible to see. 1, 2, 3, 4. It's going to come down here, and then it's going to come over to here. So this is M prime, which would be 1 comma, pardon me, 3/4 comma 3. And 1, 2, 3, 4, 5, 6, 7 times 3/4 is 21/4, which is 5 1/4. 1, 2, 3, 4, 5 1/4. That's N prime, 5 1/4 comma 0. And this is 1, 2, 3 over. 3 times 3/4 is 9/4 is 2 1/4. So it'll be right about here. And then 1, 2, 3, 4, 5, 6 times 3/4 is 18/4 is 9/2 is negative 4.5. So this is actually a fairly challenging problem. Usually we'd give you something that's all divisible by 4. So what did I say? Negative 2 1/4, negative 4.5. Let's hope that gets it done. Very, very tricky stuff. One more. We haven't done a rotation. So take a triangle. 1, 5, x, 5, 2, y, negative 1, 2, z. Just remembered. Not sure why I feel like I'm in such a rush. Didn't label these points. And I really should get a different color just so we can see what's going on. Didn't, I labeled them, I did not finish drawing things. Notice it's smaller, notice it's contracting towards the origin, because that's the point. Rotate them about the origin. So, 90 degrees, counterclockwise. Make sure we get that part down. So, if z was over 1 up 2, and I'm going, it'll go down 1 over 2. That'll be z prime. Over 1 up 5, that'll be over 5 up 1. X prime. Over 5 up 2, that'll be over 2 up 5. That might seem a little bit easy for me to do. Yeah, I've practiced. You will get it too, it's not that hard. Z prime, like I just said, negative 2, negative 1. X prime, negative 5, positive 1. And Y prime, negative 2, positive 5. That's it. Good luck, and as always, happy mathing.